We are looking at waves and wave property. We have some practice questions. We're going to do number 75 together. So this year's tower in Chicago, shown in figure 14-22, which you can't really see, sways back and forth in the wind with a frequency of about 0.12 hertz. What is the period of vibration? Okay. So when we look at this, it tells us that there is a frequency represented by our little f, and that number is 0.12 hertz. We are asked for period. Period is shown by a capital T. That's our question mark. Okay. We're going to look at our formulas. Our formula is going to show us that T equals 1 over F. Alright? Therefore, to find our period, we're going to plug those numbers into the equation. And we're going to get T equals 1 divided by 0.12 hertz. With that, we're going to get 8.3. Okay? And this is going to be in seconds for our units. And that is our answer. Now, if you're wondering how the units work, I'll quickly show you. The units work because hertz is really 1 over a second. And therefore, with our formula, we had T equals 1 over F, which showed us that we were having 1 over 0.12 hertz. This really means that we have 1 over 0.12, 1 over a second. Okay? This means that when we calculate this out, we would get 8.3 repeating, and that's really 1 over 1 over second. So we get 8.3, which is 1 times second over 1. This idea here is the reciprocal. And in the end, we find out that it's 8.3 seconds. Now, if that was confusing, understanding this concept here, how the units work, simply remember that for period, or capital T, your units are going to be seconds. Okay? So, we're going to look at number 76. Alright, we have an ocean wave as a length of 12.0 meters. A wave passes a fixed location every 3 seconds. What is the speed of the wave? Okay. First things first, we know that we have a length of 12.0 meters, which is shown by this, our wavelength, 0. Right? And we know that it's every 3 seconds. Okay, so we know a time. Okay, because we know a time, remember that frequency is found by cycles per time. This means that there's 1 cycle, or 1 wave, every 3.0 seconds. Which means that 1 divided by 3 is going to give us 0.3 repeating hertz. So we do know frequency then. Because we know frequency and we're being asked to find the speed, which is our v, we're going to have to use the equation v equals frequency multiplied by lambda, or wavelength. So now we're going to simply take our 0.3 hertz that we've calculated here and multiply it by our lambda, which we had written up here. So now we have 0.3 multiplied by 12.0. we should get 4.0 meters per second. Remember that speed is going to have meters per second. Velocity, it has magnitude. So at this point, we're not writing like that. Okay, this brings us to 77. For those of you that are feeling confident with this, you can just continue to move on. And for those of us who are having some trouble, please continue to watch. 77. Water waves in a shallow dish are 6.0 centimeters long. At one point, the water moves up and down at a rate of 4.8 oscillations per second. The oscillations means like the cycles, etc. So what is the speed of the water waves? And B, what is the period of the water waves? So we're going to do 77A. Right? We know that a wavelength equals 6.0 centimeters. Okay? We know that the frequency is 4.8 hertz. Okay? And we need to find velocity. Now, the reason we know that 4.8 oscillations per second, okay, this is just a note for you to understand. Oscillation is one cycle. Okay? So that really means that it goes either up and down, or it could be back and forth. Right? So that's what it means by that oscillation. So we do know that it's 4.8 hertz. This brings us to our equation. In the equation we have, V equals frequency multiplied by lambda, or wavelength. Plug in our numbers. Okay. So we're going to have 4.8 hertz multiplied by 6.0 centimeters, which gives us 28.8 centimeters per second, or if we convert that to meters, we have 0.29, sorry, 0.288 meters per second. Okay? Either one of these would be your correct answer. So now we're going to do B. B, once again, we know that our frequency is 4.8 hertz. This time we're being asked for a period, which is represented by the capital T. Remember, our equation for this is 1 over F. So T equals 1 divided by 4.8 hertz. Therefore, T equals 0.21 seconds. And if you need to, please refer back to the slide before in order to understand how we convert hertz to seconds, or how that works. Okay, and lastly, I'm going to do 78, and then you should be able to work on your own. So, 78. Water waves in the lake travel 3.4 meters in 1.8 seconds. The period of oscillation is 1.1 seconds. What is the speed of the water waves? What is their wavelength? So 78, we do A first. Okay. First thing that we know is that we have a distance of 3.4 meters. We have a period of 1.1 seconds, and we have a time of 1.8 seconds. Now you may be wondering, how are these times different? Okay, period, or T, is seconds per cycle. Okay? Where time, lowercase t, is just time it takes to do something. Alright? So for our first part here, velocity is what we're being asked for. Distance, we know, 3.4 meters. And time, we know, which is 1.8 seconds. We're going to use our equation, v equals distance over time. Therefore, we're going to have 3.4 meters divided by 1.8 seconds. Okay, if you calculate that out, 3.4 divided by 1.8 should get 1.88. We're going to round 1.9 meters per second. And make sure you circle your answer. Okay, this brings us to part B. B, we are being asked for the lambda, or wavelength. We don't know our frequency. We do know our period, which is 1.1 seconds. We have calculated our velocity, which is 1.9 meters per second. So there's going to be a few steps to this. First step, we're going to have to calculate our frequency, which is frequency equals 1 divided by period. Therefore, we're going to go 1 divided by 1.1x. We got from there. This is going to give us 0.9090 hertz. So now we know our frequency. We're now going to take that and put it in our second step. There's a different color for this. We're going to be in our second step. There we go, second step. V equals frequency multiplied by lambda. We need to solve to find our lambda. So we're going to divide both sides by frequency. When we do this, our frequencies cancel out, and therefore we would be left with V divided by frequency equals lambda. For some of us who like to put in the equation first and then do our math, that's fine too. So I'm going to just plug in our numbers now. V being 1.9 meters per second divided by the number that we calculated here for our hertz, 0.9090 hertz. Okay, this is going to equal 2.1 meters, which is going to be our lambda. Okay. Please remember, we talked about it before, hertz is really 1 over a second. And that's why we're able to cancel out our respective seconds. And therefore end up with our meters. Okay, so you should be able to continue with the rest of the questions. I will warn you that number 83 is pretty tough. And you should be doing either one or the other if you're doing a hard or medium assignment. The answers are up at the front, and you can see Mrs. Buddinger for those.